I'm very excited to introduce to you somebody who knows a lot about FMEAs, a lot about how you keep them alive, because that's the key message of today. And that is Mr. Jan Braaksma.
Thank you, Jeroen. It's an honor to be here and to be here with people who also like to know something more about failure mode in effect analysis. And I must be honest, not everyone is always interested in this topic. So for today, I'm already energized because of that. I'm associate professor in the chair of maintenance engineering at the University of Twente. And there, let's see if I can go to my slides. Yeah, there I'm an associate professor, and I did my PhD actually on FMEAs. So for me, it's already a time back. And nowadays, I'm also working on other topics, but that's also why I'm so excited to also share some knowledge from also that time and period. Still, I'm still busy also with looking at how we can use FMEA in a better way to enable it for continuous improvement of maintenance concepts. Sometimes that's difficult if people only talk about condition-based maintenance, predictive maintenance, and all kinds of advanced analysis. Well, I still think that an engine under it is also partly failure mode in effect analysis. Today, I want to tell you a little bit about FMEA as part of reliability-centered maintenance and how, that has been set up in the past. Also, some reasons why you should maintain FMEA documents. Of course, I also would like to give you some understanding of the problems behind keeping these documents updated, because only knowing the problems beneath it, you can also accept possible solutions, of course. And also in my studies, I came up with some principles, and I would like to share them today with you. And I hope also that we have some discussion on a few of these items. One back here. As a group, we are not only focusing on failure mode and effect analysis, but we are also looking at advanced maintenance concepts like this predictive maintenance, resilience, life cycle planning, but also the more softer sides, because what you will see also in failure mode and effect analysis is not only to have engineers on board who know how to do a certain procedure, they also need to know how to engage with people, how to let them also be part of such a process. So for us also, the more softer aspects in high reliability organizations, systems integration is also very important. Okay, now, I think I need to show this for a moment. I think that 90% of the audience should know more or less this figure. And I would like to check that if that's the case, because then I will adjust my level of talk a little bit to that. Who recognizes these steps? I think it's 40–50%, so I have to be a little bit careful. What we, of course, always do in a failure mode and effect analysis is identify these failure modes and come also with the effects. And that was also already discussed by John this morning. What is added by analysis like reliability-centered maintenance is that we also need to select the right equipment and at the end make the right maintenance decisions. And finally, of course, my pointer will not work here, is document the results in commands monitoring. This was the traditional view of doing FMEAs in a maintenance environment. And I have to make that a little bit clear that I look at FMEAs from a maintenance process, the customer service process, and not the design process. Because I think, although the analysis is more or less the same, the dynamics are quite different. And this is a picture the next speaker, Rob, will know. And this is about continuous improvement. And here you see the failure modes coming out of the FMEA in the central place. And what's interesting here is that you see the design of the asset as a kind of input, because that leads to a design with certain failure modes. But why I also took this picture is that use profile. And that means that depending on the use of a certain system, it will have certain failure modes in effect. And I think in practice, most often it's just forgotten. We just go for a machine and we do the FMEA. Well, in principle, it also really depends how this machine is being used in which environment. And I can give you one example, perhaps of a more military environment. If you have an F-16 plane flying in the Netherlands, and sometimes it's used outside the Netherlands in missions like Afghanistan, then I'm asking you, where do you think is the plane more engaged? Where does it have more, how you say it? Where? Is that in the Netherlands? Or is that in use, for example, in Afghanistan as part of a real military mission? What do you think? Afghanistan? Is there also someone who thinks the Netherlands? Yeah, perhaps? Different humidity, different circumstances.
More birds.
More?
Birds flying around.
More birds flying around? Yeah, that's also a good thing. Yeah, there are a lot of failure modes which can happen to this F-16. I agree with that. But if you look at it, when I heard this from someone, I thought directly it's Afghanistan. Because I thought, yeah, that is in a mission. This plane has to do all kinds of maneuvers, and yeah, and the dust, yeah, that will be enormous. So in the Netherlands, yeah, probably there's almost nothing happening. But it was vice versa. You stand still with the plane in the Netherlands? Yeah, but you think that's happening, but actually that is not happening. In the Netherlands, the planes are engaged in simulations and test flights and training on the Frisian Isles, for example. Then they use them at some moments to the max, what the airframe can stand off. So they just do everything they can do with these planes in the Netherlands as part of the training. Well, if they go to Afghanistan and even drop bombs, they just go really slowly off the track. They know they will not be shot out of the air with a normal speed. They come there, they open the hatch, the bomb is coming out, and they go back. Nothing happens. So from that airframe side, there is no stress at all. But of course, on the ground, you have dust. And the dust comes into the engine, and then you have a glazing effect. So what I learned from that is that you sometimes expect that something is much more heavily used in another environment, but that you have to be really careful and really study it to understand what the differences might be in the usage. So therefore, usage profile. So that's also one of the reasons for the need for a living document. These usage profiles can change over time, but also I think for ASML, if you look at these lithography machines, and they make, ultimately they are produced for customers like Samsung, Intel, and what I've heard, and I have not been myself in that production process, but they make the chips in different ways, and the chips are like buildings, designed also in different ways. So probably, I think, the usage profile might also vary because these customers do different things. So really important, I think, also in the collection of your failure modes and how you do your failure modes in effect analysis, to look at these usage profiles. First of all, also what I forgot to say is, of course, our understanding of failure modes changes over time. If we start by doing a FMEA, then we always see in practice that people think that if they have done one time an FMEA on a certain machine, that it is the perfect FMEA. I will go in more detail about that. It's always perfect. There is never a discussion, how good was that process? How good is that document? Did we include all failure modes? Did we define the failure modes in a way that we can use them later on? So I think what you see, there are a lot of uncertainties in this process. Now, then I have a few slides in memory of my old promoter, Professor Hans Wortman, who did also a lot of activities with ASML. A few PhD students have been supported by him. And what he really made really clear to me, already when I was a PhD student, I think that's more than 15 years ago, he told me what are the difficult problems of asset management and asset information management. I want to share them also in a few slides with you. Of course, we understand this. If you have asset management, and that can be the maintenance of this lithography machine, then we have decisions which relate to different phases of the life cycle. The requirements, the acquisition, its use, maintenance, refurbishment, dismantling. But for all these decisions, information is needed, quite logical. But the problem is that the supply of this information is often poor. Let's see if I can go. The question is, of course, why? What we can say is that if you look at the initial phases, Hans Wortmann makes a nice distinction. He says the initial phases are project-based. After project closure, no party is often responsible for the documentation, if you do it in the classical way. Nowadays, we know this kind of things, of course. We think it is a kind of miracle being performed. And then this is a kind of miracle with the magician. We do a kind of project. We have the rabbit is coming out. We have a certain design. We have a failure mode and effect analysis document being prepared. But the problem is nobody is interested in the rabbit anymore. After the show, then the rabbit can just go away. And that, I think, is a good one to remember this picture. That's also why I came up with Hans. Yeah, perhaps Hans will look at this and say, is this now the slide you picked out from me? But again, why is this information poor? So the initial phases are often focused on this documentation, and later on is mission-based. So during the mission is on the success, not on documentation. And that's a really important change. So we want to have success, we want to sell these machines, the machines have to make chips. And we are not looking anymore to the documents which were behind it. So we see again, first of all, these first phases are project-based, later phases are mission-based. And also the dismantling are project-based. So it's really difficult, but the crucial information we need to get, like the asset configuration, failure history, and is really important. And we have to maintain this information while we have the difference in looking at these processes. And what we also see is that the information we have from the past is just not future-proof. And you look at this kind of old things. Now this is not so long a time ago, these systems, Bond's cards. And this is, I think, a kind of hieroglyph kind of thing. I have a friend who studied one tablet, just to understand what was on the tablet. For how long did you think? As a PhD?
4 years.
4 years, yes, 4 years, one tablet. So it means that these people, when they wrote it down, they never thought that someone would study that for 4 years to just understand what is on it. And I make a little bit of the comparison with FMEA. Sometimes that's the same thing. Because if I ask people in practice to look at a traditional FMEA, which was prepared by a colleague, they think it's like this. They just don't understand it. And they say, yeah, someone was there. And then I said, hey, your name is on it. Your name is on that. Oh, yeah, was I part of that process? Yes, you were. Don't remember it anymore. So even the people, part of writing the document, don't remember anymore what was behind it. So that gave me a kind of clue that something is missing with these FMEAs. Now, other problem as well, is the only problem the information problem? No. It's the Babylonic confusion of language also, because we describe things in different ways. We record it in different ways. So we have also multiple parties who own this information, and especially in an environment of ASML. You have all these suppliers, and you are probably part of that as well. You all have a piece of the puzzle. So multiple concepts, multiple views. And of course, then also different policies. So this is a kind of background we have to work in also if we study failure mode and effect analysis. So what did I do? I looked at the failure modes and effect analysis. I was triggered by these talks that people were working on it and could not understand it. And I thought, let's look in academic work. I want to see how it's actually being done. So not a manual how to do it, because there are a lot of manuals describing how you could do failure mode effective analysis in the process and design, maintenance, but not so much on what actually happens. So what I thought, I just pick up this FMEA failure mode in effect analysis, which I showed you also at the start, and I just I'm asking some logical questions about it. What I think you could ask if you see these questions. And I also want to know if they would then deviate from what was logical from the theoretic perspective, why they would deviate from that and how we could learn from that. Now, I did it with 6 companies, not at the time with ASML, but in different industry, pharmaceutical, fossil fuel, minerals, also the number of FMEAs was different. I think this was really also on the maintenance part, I have to say, not the design part. So probably there were much more failure mode and effect analysis behind this equipment, but I looked in the maintenance phase. And I would like to know how they used these things. So I had some postulates. And the first postulate I had is that I said, yeah, if you look at this failure mode and effect analysis, theory says you have to do it in principle on a lot of assets. Yeah? But I saw also in the recent literature that they said, no, we only do it on a limited quantity. So what do you think? Is that agreed upon? Start easy. Agreed? Not agreed? Agreed? Hands up. See if my thing works. Yeah, that was supported, indeed. Then the failure modes are identified and analyzed with sufficient accuracy. There was really limited support. And then I was a bit confused because I thought that nobody in literature ever talks about this uncertainty in the outcomes. Only that you identify the failure modes, even someone who starts just identifies the failure modes. Well, there can be a lot of uncertainties. Yeah, I see someone laughing, but that's really what's happening. And you can imagine, and often, people like you are asked into a project, do the failure mode and effect analysis. If I ask this, my students who do it on a bike or a car, they already have big difficulties and don't know exactly how to do it. They ask me a lot how to write it down. Yeah, but I said, you already drive a bike for almost 20 years, or sometimes longer. And you're an engineer, yeah. And so it means it's not so easy. And if they have done it, and I have always 80 students, around 80 students in the course, and I let them do it in groups, then the 20 results are really different. So then I knew that if this is for a bike, a simple bike, what does this mean for a complex machine like a lithography machine of ASML? Think yourself about it. The clear procedure. Now, of course, that's also to be expected. There is limited support for a clear procedure. Some companies have, of course, as an internal standard, some procedures on how to use it, how to do it, but over time this changes quite often, also depending on the suppliers or the parties where they work with. So I heard for today, for example, Holland Innovative is helping ASML. They will have their own insights in that, combining with ASML, but how to keep that in a standardized way. Also, if you do the FMEA, does it lead then to a certain consistency in maintenance decision making? Because that's what you want, of course. And do we have maintenance routines fitting to this identified failure modes? What I then saw, there was totally no support. Because there seemed to be a big disconnect. Someone did this failure mode and effect analysis with a certain level of quality. And then the ultimate maintenance plan was disconnected from that reality. I was amazed. I was really amazed by seeing that. Can someone understand perhaps why that happens? Or explain from their own experience, why does this happen? You
Probably were not part of the FMEA brainstorm session.
Yeah, that's a good reason. Yes. Yeah, that is one of the reasons.
Miscommunication, different groups, and timing.
Timing.
Different groups.
Different groups.
The FMEA is done by the engineering, process engineering, and the maintenance timing.
Yeah, all good reasons. Yeah, I think one of the things is if you don't do it together or have a connection between the FMEA process and ultimately also the maintenance execution process, people just don't accept also the result. I've been at one of the companies and this guy said, yeah, a team made it, but I have a problem now, Jan. I said, what's the problem? They don't want to use it. He said, why don't they want to use it? Yeah, they don't trust it. I said, no, but how are these people involved? Yeah, they were not involved. Yeah, I said, there you have your answer. It could be that they had some good ideas, by the way, but then now it's too late and you have to convince people. Then Number 5, and we are talking today about FMEAs and continuous improvement. What was my finding here? Was it supported? No, it's already a bit obvious now. Huh? Limited. I saw here and there that there was some attempts to really start using this FMEA and look back. And so I saw also with some one of the parties in the Netherlands who was also busy with the gas transport in the Netherlands. They were really serious also on this, and they took sometimes the effort to look back at these FMEAs. But there were only a few who really did. Because when I asked questions like, where are your FMEAs? It was like I did an audit. Because they said, Jan, yeah, theoretically, they should be on the server right there. Now I said, can we go to that server? And then he opened the page for the first time. Never looked at it. Oh, Jan, here they are. Here we have 5 of them. No. So that's what I saw during these cases. I was amazed. I felt like a detective. Huh? What I also saw in the theory is FMEA is dependent on expert knowledge. The use of historical data is not possible because that was what was written down in the historical books. So if you look in the books of Bloom and also Mowbray, they say in principle it's just not possible to use data. We need expert knowledge. And I was of course interested there. And what we saw, that was supported because no one ever used any quantitative data, any data at all. These people were just sitting together. Only one company tried and just used some data and also brought that together into the sessions. So what did I learn from this? That I thought, hey, here's space for research. Here I can do a PhD on this topic. So that was what I saw here, copying here. So to conclude again, I saw that these capital goods were selected on basis of criticality. Not all assets were selected. I think that's reasonable because if you want to select and you do an FMEA on all assets in all components, you can calculate how many man-years you will need. In principle, that's almost not possible. So you have to make some kind of selection. The selection, what I saw, is then needed to be a kind of objectified, but was really not there. So I saw also that the FMEA was done on parts of assets or components, but I could never retrace why they did it. What was the reason behind it? Why did they do this FMEAs first or later? The procedures were not there, and it was really seen as a one-off exercise. Well, literature says FMEA should be a living document. Doesn't really explain how it should then be a living document, but it should be living. Huh? Yeah. What is it, a living document?
We still find out.
Yeah, of course. So therefore, there was also no quality improvement cycle. And I agree today, quality, there it starts with. So also FMEAs are important for this quality improvement cycle. Minimal use of quantitative data. Well, I saw already in 2013 that a lot of failure and process data was just available in these systems. And at that moment, they were already building big databases. So I thought, why just not try to use some of these data? And the registration of these FMEAs also hindered reuse. And I can give one anecdote about that. I was with a guy, and by kind of coincidence today, I saw also he emailed me for another event. And he said, Jan, I am so proud. I'm doing FMEA analysis. I'm a facilitator, and I think I'm doing it really right. Can you come to visit me? And I want to show you how I'm doing the process. Now I said, that's nice. I will come to you. And he said, no, look at my fancy system. He had a really information system tool, and he had a team, and he showed that all the steps were taken care of. I said, that's nice. And I said, by the way, what are you doing with the results? Yeah, it's stored in this database. Yeah, but I said, if you go away, where is this database then? Yeah, on the employee storage disk drive, it's there. Oh, I said, okay, then it's good, it's there. Then a year later, I had another one in my professional course, and I said, hey, there was this guy, and I visited you. I would like to know what happened, because it's like a story always, with failure mode and effect analysis. You can have many years of work on this. And this guy said, who are you mentioning? Yeah, he left, and yeah, but I said these FMEAs. FMEAs? I don't know. Yeah, but he worked on this plant with a team 1.5 years. I said, quite a lot of efforts have been put in it and also money, I think. No, I don't know. We started another project. So he was just busy again with the same thing, not even remembering what happened, not even remembering what happened. So this registration, really an issue. So we have to look in this number 7 issue, I think. So that's also what I did. I think this documentation of results is not going right. So what I thought, or I think are enablers of continuous improvement is that you need to think early about the future improvement. So because there is a time disconnect between the analysis you do and also the future use, you have to think already at the moment you do the FMEA also about its improvement. And that's a bit strange because and what Hans Wortman was telling us is we are mission based and we are not looking at these documents. Well, these documents are also really important. I think also quantitative possibilities are now there. I think what the ASML is trying also with artificial intelligence, perhaps it's sometimes almost too fancy, you could say, but I think there are a lot of interesting techniques we can try to use. A third element I think I learned is that we have to work also on criticality if it goes to asset information management. Also today I saw so many information processes, things flowing over. If you want to improve a failure mode in effect analysis, we have to know also which information we want to use in the future to improve it. And or what information, perhaps if we don't have it yet, how do we want to collect that? And how do we want to be sure that we get this information to be able to do another analysis? So we have to also think about that as well. And you can imagine that for a lot of normal companies, and I mean with ASML everything is stored in systems, but if you look at the more traditional companies, also then the normal maintainers, the operators are really key in getting this information. They have to write down if a failure occurs, what were the reasons behind it, what was the failure mode, and what, if they do a kind of failure analysis, that they really describe some elements and don't just say, and what is normally happening if something fails? It doesn't work, failed. So if you look in this history, often you cannot use it because it's just it has no details. So that's why I say you have to do it based on criticality, but you also have to take the whole supply chain into account, and you have to take this operator and maintainer with you, and knowing that these kind of systems are important, or at least some failure modes of these systems are important. Because if you don't do that, I see that in some companies they say, yeah, information management is important and we do information management on everything. And we want to improve that on all assets and all components. Then what happens? Then the people who have this knowledge are going to describe that and put that in systems. But what I saw then happening is that then you also have to have the capacity to follow up on this information. So if you only have then the input data there and don't follow up, yeah, what happens then? So I saw these operators trying to do a lot of work, describing the failures. They never got feedback because there was no capacity. Then after a year or so, they stop again. So be really mindful of that as well. Now, I think also the information architecture needs improvement. And I think also with ASML, I'm working now on a PDN project to also look at the use of standards for the scales, but also for the failure mode description. Because you can imagine for a bike, perhaps you can go to a kind of standardized process on how to define a certain failure mode. But if you look at these complex machines ASML is making, then this is really key, yeah? Because everyone probably has another thought about what is the failure mode. And thirdly, the human factor. I think it has not been mentioned today, but really important how to engage people with you already in the FMEA process, yeah, to have the people also joining you, also to facilitate it in the right way. Yeah, with 25 people, it's undoable, but doing it alone, yeah, probably you will not have the knowledge yourself. So you have to get the right people in at the right moment, give them the floor at the right moment, and also stop them at the right moment. So I already see on my time, I have still 60 minutes and then I'm being stopped. But that's also what the facilitator needs to do with FMEAs, because then only one person is talking and the other one who has the knowledge doesn't say anything. So also this motivation for better registration and asset information is really important. But I think I asked also yesterday my students, how do you think we can motivate people? And then what did they say? Yeah, give them more salary, pay them for it. And then another student said, yeah, but that works only once. And I think, yeah, so what you need to do is that there is a kind of intrinsic motivation, that people also feel that if they do it, they get reward for that, and not reward in the sense of money, but that they say, hey, you have been part of the improvement process. I also give feedback to you. And therefore you have to be careful asking people also to describe things. Be clear that you do it on some assets perhaps more intensively than on others, so that they have focus for that year, you could say. Other things. So it's about proactive management and registration of future needed data as well. And I think what we need also is an improved rationale behind the FMEA the decision process. So it's about what has happened. So what was the scope of the assignment, the team, what was the knowledge, this kind of things. Did you ever see them on an FMEA sheet? Yeah, also with an OS. Then I would like to see it, I must say, because I have never seen it until now. I never see it, because I think the only way to appreciate also the quality of an FMEA is also to see what kind of knowledge has been involved, what people were there, what was the process, what were the decisions, but also where were the uncertainties. So like the last one, if you have a group of people, even on that bike, they will say, yeah, we know a little bit about this, but yeah, this specific braking system, I have never had this with brake pads, so I don't know so much. Then you should also write down in your analysis, like for this component of the system, we did a basic analysis, but we must be clear here, we have not expert knowledge on this. So probably there can be some improvements on that. So be honest. But why doesn't it happen? And I also asked it my students yesterday, but I'm also curious why you think, why are we not putting our uncertainties on paper? Or you could also say positively, the improvement potential.
Extra administration burden.
And the administrative burden?
Oh, you mentioned you can also bring it positively. But I think people don't want to show what they don't know.
That's it. I think that one of the elements is that people don't want to show that they don't know everything, and they probably think that the party who is asking them to do failure mode and effects, that they have a perfect knowledge of that machine. Well, in reality, no one has. So I think it's a kind of assumption that we think that these FMEAs are perfect. Well, in practice, they are not. And I think the best FMEAs are the FMEAs where you also are describing where you had the knowledge, you think you had more knowledge, and where you think you could do the improvement. And I agree with you, that can be a little bit of an administrative burden, but it then depends on what level you register that. Because you can do that really detailed on a failure mode level, but you could also start by doing that on a component level, or even a module level, that you say, hey, we have studied this module, and we think that in this area, that we are more sure than in others. Because if you do that, then, and if your colleague then reads this file, he can have a much better appreciation of that work. Huh?
Can I add something?
Yeah.
I think it's also human nature to describe what you know. Because you're not going to put your last slide on all the stuff you didn't do during your PhD either, right?
No, yeah, we don't. We do.
Yeah, for the research.
And we always mention, Rob knows, future research. And we say also what is lacking. We even describe that in a paragraph, that we say we did 1 or 2 cases. Probably this could be improved by doing another 2 or 3 cases. We did use this method. We could have used that method. So to be honest, as researchers, we do that. So I think perhaps we need to also put that research perspective also on these FMEAs, because at the moment we are doing these FMEAs, we are actually doing a kind of research.
Yeah, exactly. So it might be the nature then.
Yeah, no, people are not used to do it. So, but that's also why I'm sharing it with you today. People are not used to it, but I think if you are someone who asks someone else to do with FMEA, also be clear beforehand that it is not an issue to be sharing your uncertainties or your improvement potential. Now, and then I want to show you this process I propose, and then I want to also, let's see, I have still 11 minutes, and I have some time also for discussion. If you look at the left, that's the traditional failure mode in effect analysis with these 7 steps, or perhaps 8 steps, it's how you look at it. Then what I propose is that if you do the failure mode in effect analysis, you should do 3, 4 additional steps. And you can decide on what level you want to do it. Do you want to do it on the functional level, and the function step 1, or do you want to do it at a more detailed level on the failure mode level? But what I say, determine then, based on the uncertainties you have seen or the improvement potential you see, if feedback is needed and perhaps worthwhile. Because you have a kind of feeling already at that moment, and of course it's difficult, but probably you know for 20% that it is quite good and you're quite sure about it. But for other parts you might think it's interesting to take another look. For example, if we get the real data from the field. For example, that we say we have done this failure mode in effect analysis. We have now brought it to the customer, and we want to look at it in a year on some aspects. Perhaps we don't want to study everything, but here I'm asking then, what will then be the most interesting parts? Then we can also ask ourselves, if we think that's worthwhile, what are then the requirements for the feedback? Now, we could use, of course, quantitative data, but perhaps sometimes expert data is sufficient. That you say, we want that some people on the sites, on the location, perhaps draw up some memos or reports, and then in half a year, we go to them and ask them back what their findings were. But we think of beforehand what we would like to receive. Then we, of course, have to organize that, because that's also a step we often forget. We just think it's in the system. Now, it's often not in the system, because a lot of things are being put in the information system, but often the data you need, it's always the problem is just not there. So you have to organize that. And even make sure that then also these outcomes are used, so that you get the data and also use these data in a process to look back at analysis. So you need to organize more or less 4 steps. But I think if you do that at a high level for a component or a subsystem, I think you're already making a step, because what you're doing at that moment is already looking what is the next step after this failure mode in effect analysis. And probably you don't know everything, but I think it already can initiate the kind of process towards this kind of improvement loops. Because if you just say, this is my FMEA and I'm now so happy, my mission is accomplished and that was it, then you know this improvement cycle will just not come. So I think you have a responsibility also as an FMEA facilitator also to think about future improvement. And you don't need to put everything there, but give a few clues to the person after you. So that's more or less what I wanted to say to you, and I'm now curious if you have questions. Yeah.
Wait. Before we go to questions, we have mics for that.
I heard, by the way, that in front it can be heard quite well, but if you go for the 4th or 5th row, then at home it's really difficult. Yeah.
Yeah, I have a question for the previous slide where you say, how much time do you think this will take for instance, gathering all the information at customers for ASML, if you want to have really data?
That depends. But I think if you want a lot of data, that will be difficult. And I can imagine that there will be other problems as well. Because if you look, I've been with also a company who was in the defense industry. And they said to me, can your students say, if we get all the data from the customer, what can we do then with that data? Yeah, I said it's a hypothetical question indeed. Huh? But I said, will they provide you the data? Yeah. And I think that's the problem also in this industry, exactly. That they will not give you all the data because there are all reasons for that. And the data can be used in different ways. Mm-hmm. But I think important for ASML is then to really think, where do I want the data? Mm-hmm. And what kind of data, perhaps also just experience. Try to explain that and also, I think, to these customers and why you need it, what you will be doing with it, how you can use it in your feedback process. And then you might convince, I think, also that party to say, okay, you will not get all data, but we will give you a reduced set and we will provide you with some feedback. So I think you have to do it criticality based. And of course, you cannot get all data. So you have to be really selective. That's, I think, my advice here. But I can imagine if you just say to the customer, give me all the data, it's undoable. And they also will not give it.
Okay, yeah, that's what I recognize, because I think it can take months. So I don't know, then we have to plan this in advance, that we start.
Yes, but what my point is here, determine first if it's worthwhile. That's important, because if you don't have a business case here, stop. Then also see what kind of requirements do you have. Then you have to be realistic. If you're not realistic here, or it is just not possible, you also have to stop here. So you have to define something which is realistic. Then also this has to be realistic. So I just say, don't make it too difficult, but start up by probably the low-hanging fruit, because there are probably some systems you don't know too much about. You really want to know how they are used in the field. Start up some processes on that. And perhaps if you are in a conversation, you get more and more data. But I think this is the right moment to already start that discussion. Because then at that moment, also the knowledge is there. If you are in the situation that there are problems with the machines, then they don't know how these failure modes have been identified. So I think that's the reason why you should start early. So I hope it answers your question a little bit.
Yeah. I'm only concerned about the timing that it will take here.
Yeah, but it will take even more time if you don't set up this process beforehand, because what's normally happening is that there are, that's in my, let's see, I have it, did I put it in, perhaps I didn't put it in my presentation. But what's normally happening is that there are disconnects in time between these process steps, because what you normally do, you have this RCM analysis, and then you find out something is wrong. Something is happening in reality, you have big issues. Then you are going to discuss with the team, and then you say, there is something wrong, but we need data. We need more analysis. Then you have to organize this data analysis still, and you have to get the data back. So if you do this already beforehand or start it up to some extent, you already have some initiations there, you could say. So that's the thought behind it.
I want to tag in here now because I saw some other questions as well, and I want to make sure that everyone has a platform. So one,
So in a moment we also go to the back.
Hello, Jan. My name is Henk Velten of Sensata. Thank you, by the way, for the presentation to see the practical difficulties that you meet in executing FMEAs. My question is about the experts that you bring together in the team. That's the first thing. You don't want to do the FMEA with students. You want to find, as close as possible, all failure causes or all failure modes. And what we see that sometimes, even if you bring the experts together, they may not find all failure causes or failure modes because they may have forgotten things. Their data may not be accurate in their memory.
No.
The machine may, or the system may be new. And my question is, what tools or tactics do you see to help even the experts to, as close as possible, find all potential failure causes and failure modes?
Yeah, if you just don't have information, of course, and you don't know the system, how it behaves, then it will be really difficult. I think, of course, people can go in a session together and try to look into it and see if they can relate it to existing knowledge or a machine who is more or less comparable. There is always something where you can perhaps compare it with. But I think at a certain moment, you also have to be realistic in your reporting. Then you say, we had all the experts on board. We couldn't ask more. And we still are unsure. And then this kind of process is needed. And you just say, hey, okay, we came to a certain level and we tried our best, but we need a next step. And then if you already organize then the next event, you're already doing a living FMEA program. Of course, it will not go automatically just by organizing the next event. You have probably to do something in the meantime. You have to study the machine. You have to look at how things are going and then use that knowledge for a second session. Yeah.
Okay,
so that's my answer there.
I see we have questions.
And in the back,
I
promise
question.
there.
Thank you.
I'm going to keep it a little bit short, but one final question.
Yeah, 2 minutes, I see.
Hey, Jan, thank you for the interesting presentation. A lot of thoughts are provoked on my end and also questions. But for today, I would keep one question. Where do you see in the industry that this process is focused? Do you see this in quality management handbooks or management handbooks? Because I think it only flies if it's structurally made somewhere really required. So what are your thoughts and answers on that?
Yeah, it's a good question. When I did my PhD on that subject, I expected that industry did a lot already on that, also in the field. And I also ask my students often, and they think, yeah, it's there, and they do a lot of quantitative analysis. I even asked, how often do you think a failure mode and effectiveness analysis is done? And then they said to me, first student, every time there is a failure, Jan. And I said, no. I said, I'm already happy if I see it happening once again. And oh, is that really the case? Yes, I said, in principle, it's never looked back. So I think it's about procedures, but also I think it's about change management. A culture needs to be there that it supports this kind of analysis, and I think if you look at the principles of Kotter, you can look them up on your cell phone. One of the important things there is to organize a kind of leading team. Also have some first low-hanging fruit, so that you get your first successes together, and see it as a kind of change process to establish these kind of things together with the FMEAs. And it's really often lost, because if you facilitate FMEAs in a terrible way, and you already said so, share that stories, often then a lot of money is already spent by companies, sometimes a few million euros. And I heard that often, and then it's a kind of disaster story. And I said, oh, Jan, you are there and you want to study FMEAs. Please, Jan, go out of this room, because we don't want to discuss that trauma we had. And by the way, we will not finance any money on that topic anymore the coming years. And then I think you will have a problem with your maintenance concept development. But they just say, yeah, we spent 2 million. It's done. So also what I want to say here, if you spend money on failure mode and effect analysis, spend it wisely, and perhaps don't do it too big at the start, but really also invest in improving your process and get the culture around it. I think an event as today is really important also in that as well.
Yeah, and you gave a good example yourself, explaining the story of the guy.
Well, I have to ask
Let
you
me just ask the
that
question
we leave
because I
this here
didn't
and
get
that
an
we
answer.
continue this discussion at lunch.
I will discuss with you in lunch. No problem.
Well, let's give everyone, let's give him a warm applause. Dankjewel.